we tested the speed versus stopping distance by my highly trained team of scientists, Michael, Eric, and Brian.
Yes.
Our observations, we saw the speed of an object and the braking distance and wondered what the relationship of these two variables were. We just sat on one sunny day just wondering what the relationship is. Our question was, is the relationship to speed and stopping distance with a Hot Wheels car rolling down a ramp at different parts of the ramp? Now, we wondered to see if this relationship was going to be the same with small objects and large objects. So we started with the small object. Our hypothesis is, if we test the different speeds with a marble traveling down a ramp, then will the marble break at an inversely rate because it will slowly decrease slower every second? Interesting. Our variables were, the independent variable was starting distance on the ramp, so where we start, it will change the dependent variable, which is stopping distance, so the higher up on the ramp is going to be the larger stopping distance, we believed. And the constants was the Hot Wheels. We weren't going to change what we were pulling down the ramp. And the materials we had to use was not a marble, but a Hot Wheels car, which was 40.1 grams. A Hot Wheels ramp, which was 104 centimeters long, and a computer with a Veneer Logopro, a camera to record, and masking tape and meter stick and ruler to measure. Our procedure was, tape one end of a Hot Wheels track to a surface perpendicular to the ground, 1 meter high. Place the 0 mark on the meter stick to the other end of the track, parallel to the track. Measure 10 centimeters, 20 centimeters, 30 centimeters, and etc. as long as you want to test, behind the meter stick on the track, and put the tape marks for each measurement. Tape meter sticks in place. Place the front of the Hot Wheels car at 10 centimeters. Observe how it is on the track and record the centimeters it took to come to a stop from the front. Take 2 more trials from 10 centimeters. Repeat 5 and 6 with 3 trials for both 20 centimeters, 30 centimeters, and etc. Procedure continued. Here is a little clip of our procedure. Here, don't look at this stuff. Okay. Here's what it looked like. Shh, don't watch it, don't watch it, don't watch it yet. Wasn't that beautiful? Okay, back to the PowerPoint. What's going on? Our data was 10 centimeters. We saw that it took a 15 centimeters for the stopping distance, and then we saw 15.5 and a 15.5, another 15.5. So we came to the conclusion that at 10 centimeters up the ramp, it took 15 centimeters to come to a stop. And we saw this with each data. At 60 centimeters, it took a whole up to 101 centimeters to stop after completely coming to a stop. And here's our graph that we see looks pretty exponential as the speed increases. We see the stopping distance increasing, doubling, and exponentially. So this was pretty interesting. And so the x-axis should be speed, and the y-axis is stopping distance. And then, yes. Then here's our analysis. We came to a conclusion that it was a line of x squared. This is relationship to speed and stopping distance is exponentially, as I said in the slide before. So we believe that if we kept testing this, that you just square the miles per hour, and that's how long it will take to get to stop distance. Thank you. And our conclusion, if we test our Hot Wheels car traveling down the ramp at different heights, then the Hot Wheels will break at an inversely rate because it will slowly decrease every mile per hour it goes higher. My data will not support my hypothesis, as we thought it was an inverse equation when we learned it to be
exponential.
Error analysis. Well, we did not measure how high the ramp was on the wall, so when we came back to do our other experiments, it was hard to get an exact measurement. So some of the trials may have been done at different
heights.
Extension. So we wondered, with this data that we learned, does this data also prove the same relationship for acceleration? Does this work on a zero-gravity environment? Can we use this information to improve the braking system in
cars?
And our group members.
I burned for myself, the builder of experiments.
Brian, oh my god, no, I'm so sorry. Brian Sevener, data collector and co-work PowerPoint maker. And then, drum roll please, Michael Maganev, PowerPoint maker.
Yeah.
And thank you, that is all for today. Come back and learn more with our highly trained team scientists.